Hello students, welcome to my YouTube channel. In this video lecture, we will solve the next 10 questions from mid-course test Oxford General Navigation book. In previous lectures, I solved first 30 questions. I hope you have understood them, and I also hope that you enjoy this lecture and learn also. So let's start with question 31. Simple and very often asked question. Actual time of arrival at X is 1420. Estimated time of arrival at Y is 1447. Actual time of arrival at Y is 1450. What is the new estimated time of arrival at Z, Zulu? So look, the distance between X to Y is 30 nautical miles. The time between X to Y is 1450. That is 1450 minus 1420. You departed from X at 1420 and you have reached Y at 1450. That is the actual time. Estimated time of arrival at Y says 1447. That is an estimate, theoretical. But in actual conditions, you have reached Y at 1450. So you use that time and proceed with your sum. Now speed between X to Y will be equal to distance distance between X to Y by time. So distance is 30, time is 30 minutes, so 0.5 hour, that is nothing but 15, correction, 60 knots. Okay, so speed between X to Y is 60 knots. Now with this speed, we have to calculate time at Zulu. So look, the distance between Yankee and Zulu is 20 miles. The speed between them is 60 knots. The time between them will be equal to distance by speed 20 by 60, which is equal to 18 or approximately 20 minutes. 20 minutes. So this is how you do this sum. Very simple and important. Question 32. Heading is given, task is given, winds are given. What is your true track? Use your CX3. Heading is 156. True speed is 320 and 130 at 45. So this gives us a true course of 160. Okay. So the correct answer will be, what is your true track? It is 160 degrees. Next, question 33. You are flying at a true Mach number of 0.72 in a temperature of minus 45. At 10 o'clock, you are 100 miles away from a particular DME. An estimated time of arrival at that DME is 10 hours 12 minutes. ATC asks you to slow down to be at that DME at 10:16, 4 minutes later. What should your new Mach number be if you reduce speed at 100 nautical miles to go? You are flying at a true Mach number of 0.72 in a static air temperature minus 45. At 10 o'clock, you are 100 miles away from a DME station and your estimated time of arrival is 10 hours 12 minutes. ATC has asked you to slow down so as to be at DME station at 10:16. What should your new Mach number be if you reduce speed at 100 miles to go? So your aircraft is 100 miles away from the DME station and the time is 10 o'clock. Your estimated time of arrival at DME station is 10 o'clock 12 minutes. So that means the speed of this aircraft will be equal to distance divided by time. Distance is 100, time is 12 minutes. So 100 divided by 12 equal to 500 knots. That means the initial true airspeed of your aircraft is 500 knots. Okay. Next, ATC has asked you to slow down your aircraft so as to reach the station at DME station at 10 o'clock 10:16. 4 minutes later. To reach your DME station 4 minutes later. The distance is going to remain the same 100 and 10 o'clock is the starting point. So to arrive 4 minutes later, you will have to cut down your speed by some value. So your true airspeed will be equal to distance by time. 100 divided by, now time will be 16 minutes. Instead of 12 minutes, it will be 16 minutes. So 100 divided by 16 is equal to 375 knots. So this is your final true airspeed. So final true airspeed is equal to 375 knots. So if you want to reach the DME station at 10:12, you should fly at a speed of 500 knots. In order to reach 4 minutes late, you should fly at a true airspeed of 375 knots. So now we have to find out new Mach number. With this true airspeed, your Mach number as given in the question is 0.72. Now with this new final true airspeed, what will be your new Mach number be? We have to find that out. Okay, new Mach number. So we know that Mach number is equal to true airspeed divided by local speed of sound. So Mach number is proportional to true airspeed. That means Mach number 1 equals to true airspeed 1. Mach number 2 equals to true airspeed by 2. Now what is Mach 1? That is initial Mach number given 0.72. What is initial true airspeed? It is 500. We have to find new Mach number and new true airspeed is 375. It is 375. Therefore, Mach 2 equals to 375 into 0.72 divided by 500. So 375 into 0.72 divided by 500 is 0.54. So the new Mach number is 0.54. Okay. So you have to select the option which is closest to this option. Overall, this is how you solve this question. Next, question 34. Track is 090, TAS is there, winds are there, variation is there, deviation is there. What is compass heading and ground speed? In order to find compass heading, we must first find true heading. Let's use CX3. So true course is 90, TAS is 460, winds 360 at 10, at 90, TAS 50, TAS is 460. You get a true heading of 077 and a ground speed of 449. So ground speed of 449, a true heading of 077, variation is 10 east, variation is magnetic least, so magnetic direction will be 067, deviation is -2, that is 2 degree west, deviation west compass will be best, so magnetic compass direction will be 069. So what will be the compass heading? 069er, ground speed 449. Next, question 35. You leave A to fly to Bravo, which is 475 miles away. So A to B is 475. 10 o'clock. Your estimated time of arrival at Bravo is 1130. That is 1.5 hours after later. At 10:40, you are 190 nautical miles from A. At 10:40, you are 190 miles from A. What ground speed is required to arrive on time at Bravo? So we will have to solve this question in two steps. First, the distance between Alpha and Charlie is 190. The time between Alpha and Charlie is 40 minutes. So ground speed will be equal to distance by time 190 by 40 minutes is equal to 285 knots. Next is the 285 knots. Now remaining distance is 475 minus 190, 285. Distance between C and Bravo is 285. Ground speed is 285 knots. Time. You have to reach Bravo at 11:30. Departure time is 1040. Destination time is 1130. Now the question states you must reach your destination at this time, strictly at this time, 1130. That means this initial ground speed must be changed to a final ground speed. You will have to fly at a speed which is faster than 285 or more than 285, right? So time available on your hand is 11 hours 30 minutes minus 10 hours 40 minutes, 50 minutes. So the new speed that you must fly at is 285 divided by 0050 is equal to 342 knots. So initial ground speed is 285 knots, but if you continue to fly at that speed, you will reach your destination much later than 11 hours 30 minutes. To reach your destination on time, you will have to increase your speed. So new speed will be 342 knots. So what ground speed is required? It is ground speed required to reach destination on time is 342. Question 36. Winds are given, heading is given, task is given. What is track and ground speed? So let's use CX3. Winds are 359 at 25 knots. Heading 180 as 198. So ground speed is 223 and course is 180. So course is also 180 and ground speed is 223. Simple. Next. Question 37. Aircraft is climbing on a constant speed in ISA conditions. What will be the effect on true airspeed and Mach number? So when you climb to higher altitudes, static pressure decreases, atmospheric pressure decreases. Indicated airspeed is a function of pressure, dynamic pressure, right? So if atmospheric pressure decreases, dynamic pressure will also correspondingly decrease. As a result, your indicated airspeed will decrease. In order to fly at a constant indicated airspeed, in order to prevent or avoid fall in indicated airspeed, you will have to increase the airspeed of your aircraft to prevent indicated airspeed from decreasing. Okay, so as you climb to higher altitudes, what will be the effect on TAS? Your true airspeed should increase. So Charlie and Delta are eliminated. Now Mach number. Mach number is directly proportional to true airspeed, right? Let's take two conditions. Situation 1, situation 2. Flying at mean sea level, the true airspeed of 500 knots and a local speed of sound 1000 knots. Similarly, here local speed of sound is 1000 knots, but since you want to climb at constant calibrated airspeed, you should increase your true airspeed like I have mentioned here. So in this case, situation 2, you will have to increase your true airspeed. Let's take it 700. And situation 1, Mach number will be 500 by 1000, which is zero point 0.5. And here the Mach number will be 700 divided by 1000, which will be 0.7. So what has happened? When task increases, Mach number also increases. So the correct option will be option Bravo. Both increase. Okay. Question 38. Convert 70 meter per second into knots. Now 1 knot is equal to 0.515 meter per second. Therefore 70 meter per second will be equal to 136 knots. Simple cross multiplication. Remember this identity. 1 knot equals to 0.515. Airfield elevation is 1000 feet. QNH is 988. Let's draw. Let's say this is your airfield. Elevation is always measured from mean sea level. This is your mean sea level QNH 988. Elevation is 1000. What is pressure altitude? Pressure altitude is measured from 1013 pressure datum, standard pressure setting. Now, higher the pressure, okay, so higher the pressure, higher or deeper, deeper in the earth will that pressure level will be found. So 1013 is more than 988. So 1013 pressure level will be much deeper in the earth than 988 pressure level, meaning 1013 pressure level below will be found below QNH pressure level. Okay, that means more inside the earth, deeper in the earth. So I'm writing here 1013. Now we have to find pressure altitude. So to find pressure altitude, you will have to measure your vertical distance from 1013 pressure level. Now we know this much is 1000 feet. So we have to find this little extra value in order to find this entire pressure altitude. Now the difference between two pressure levels 1013 and 988 is equal to 1013 minus 988 25. Okay, that is equal to a height difference of 25 into 27, 675 feet. That means this is equal to 675. So therefore, pressure altitude will be equal to 1000 plus 675, which is equal to 1675 feet. Okay, the entire measurement, the full measurement. Question 40. You are flying from A to B with a planned track of 245, distance 225, speed is there. 15 minutes you fix your position 3 nautical mile left of planned track. A, B, track is 245. Next, distance is 225. Speed is 180 knots. After 15 minutes flying, that is, let's name it C. So after 15 minutes of flying, that is time between A to C is 15 minutes. Ground speed is 180 knots. Distance will be equal to speed into time, 180 into 15 minutes, which will be equal to 45 nautical miles. So AC distance is 45. Therefore, BC will be 225 minus 45, 180. Next, which of the following statements is correct? Basically, question 40. You have to calculate drift. Your drift is 2-degree port. Your drift is 4-degree port. You should turn 5-degree right to go directly to B. You should go 8-degree right to go directly to B. So we have to use track error and closing angle method. So this is your starting point at A. You have deviated here and now you want to go directly to destination Bravo. So you will have to fly, correction, you will have to use track error and closing angle method. So let's find track error first. Track error is distance of track, distance gone into 60. Distance of track is 3, distance gone is 45 into 60. So 3 into 60 divided by 45 is 4. So track error angle is 4 degree. Track error angle is 4 degree. This angle will also be equal to 4 degree. Corresponding angles are equal. Now let's find closing angle, which is this angle. Closing angle equals to, again, distance of track to 60 by distance remaining. So 3 divided by 140, 180 into 60, which is 1 degree. Okay. So closing angle is 1 degree. Now if this is 1 degree, this angle will also be equal to 1 degree. Closing alternate angles are equal. So what is our final change in heading? So final, therefore total heading change required to go to destination Bravo is equal to 4 plus 1, which is equal to 5 degree right. So that means your plane will have to turn 5 degree right hand side or starboard side in order to reach your destination Bravo. Directly reach destination Bravo. Okay. Next. So this is the correct answer is option Charlie. You should turn 5 degrees starboard or right to go directly to B. Now drift. Is it possible to calculate drift in this question? No, because drift is nothing but the angle between heading and track. In this question, you have been only provided with track information, not heading information. So you cannot, it's impossible to find out drift. So we are left with options Charlie and Delta, out of which Charlie is the correct option. With this question, we come to the end of this lecture. I hope you have understood all the questions I have solved. You have liked this video lecture, you have enjoyed it, and I urge you all to keep practicing these questions again and again till you gain proficiency in them. More practice, more confidence. If you have any questions, doubts, or feedback, let me know in the comment box of this video lecture. I'll definitely read them. Subscribe to this channel if you haven't yet. Share this video with all your friends, please, and like this video lecture. All the best. See you in the next lecture.